My dear students and parents, by God's grace, my educational videos are available in the YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects Maths, Physics, Chemistry, Zoology and Botany in English language. Today, we are going to find the potential at a point P due to a point charge and also the work done to bring another charge to that point P. Let us go to the sum. Calculate the potential at a point P due to a charge of 4 into 10 to the power of minus 7 coulomb located 9 centimeter away. The second question B is, hence obtain the work done in bringing a charge of 2 into 10 to the power of minus 9 coulomb from infinity to the point P. Does the answer depend upon the path along which the charge is brought? First, we are going to do the sum A. In this sum, it is asked to find the electric potential at a point P. That point P is placed at a distance of 9 centimeter from the charge 4 into 10 to the power of minus 7 coulomb. At this place, it will be appropriate to know the definition of electric potential at a point due to the point charge and the electric potential energy and also the electric potential at a point due to dipole. What is the definition of electric potential at a point due to a point charge? It is the work done to move the unit positive charge from infinity to a point at which we are going to find the potential. It is the work done. For which purpose the work is done? The work is done to move the charge. How much charge is to be moved in the case of electric potential? The one unit positive charge is to be moved. From where to where it is to be moved? From infinity to a point. At which point? At the point at which we are going to find the potential. Next, that we are going to see the definition of electric potential energy. It is also work done to move the charge, but here one unit charge is not moved. Certain amount of charge Q2 is moved. If we take the source charge as Q1, the charge Q2 is to be moved. From where to where it is to be moved? From infinity to a point at which we are going to find the electric potential energy. In both the cases, that is in respect of electric potential and in the case of electric potential energy, the work is done against the electric force. What is the formula for electric potential? The formula for the electric potential is 1 by 4 pi epsilon naught Q by R. We can write small q or capital Q. The capital Q or the small q at this place represents the source charge. What is source charge? The source charge is 1 which produces the electric field. The formula for the electric potential energy, that is work done, is W or U. W is the work done, U is the electric potential energy, equal to 1 by 4 pi epsilon naught Q1 Q2 by R. Q1 is the source charge, Q2 is the test charge. We can also write capital Q into small q. The capital Q or Q1 is the source charge, as we already told. The Q2 charge or the charge Q is the test charge. What is test charge? It is the charge which tests the effect of the source charge. Then the formula for electric potential at a point due to dipole, capital V equal to 1 by 4 pi epsilon naught P cos theta by R square. In this case, P represents the dipole moment. Why I am telling these three formulas at this place? Because we should not confuse, that is, we should not interchange the formula for the electric potential at a point due to the point charge and the formula for the electric potential at a point due to dipole. In this case, the dipole is not provided. So the formula to be selected is potential at the point P is capital V equal to 1 by 4 pi epsilon naught capital Q by R. This Q represents the source charge. On seeing this equation, we understand that there is only one data in the left side. In the right side, there are three datas. One is 1 by 4 pi epsilon naught. The second is capital Q, that is source charge. And the third is the distance R. I have already explained in so many times, from one equation we can find the value of only one unknown data subject to the condition if we know the values of all other data. Here we have to find the potential, that is capital V. So in order to find the capital V, that is potential, we should definitely know the values of 1 by 4 pi epsilon naught Q and R. The Q is given as 4 into 10 to the power of minus 7 coulomb. So it is okay. The distance is given as R equal to 9 centimeter. So R is also given. We know that the value of the 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 Newton meter square per coulomb square. So we are having all the three data required to find the potential. Before proceeding to do the sum, we should convert the centimeter into meter. The reason is the correct unit of distance is meter. Therefore, we should know the relation between centimeter and meter. We know that 1 meter contains 100 centimeter. 1 meter equal to 100 centimeter. This equation should be changed into the form of a fraction. In that fraction, in the numerator, the unit which is to be found should be placed. We are going to find the meter. to certain centimeter, so that meter should be placed in the numerator, and its relation 100 centimeter to be placed in the denominator. So what is the meaning of this? 200 centimeter, the meter is 1. Therefore, to the given 9 centimeter, what will be the meter? So that I am writing in this format. This format will be useful in order to do any sums at any places. So if we remove the words, we will get 9 centimeter equal to 9 by 100 meter. If we substitute 1 by 4 pi epsilon naught Q and R, we can find the potential at the point P, that is V equal to 1 by 4 pi epsilon naught Q by R. We have already discussed the value of 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. So we can substitute 9 into 10 to the power of 9 in the place of 1 by 4 pi epsilon naught. The charge is given as 4 into 10 to the power of minus 7 coulomb. So that we can substitute 4 into 10 to the power of minus 7 in the place of Q. Moreover, the distance is given as 9 centimeter. We are converting that 9 centimeter as meter. If the fraction comes as denominator, we can reciprocate and multiply. So if we reciprocate the denominator, that is 9 by 100, the 100 will be brought to the numerator. Now we are getting the equation for electric potential at the point P. V equal to 9 into 10 to the power of 9 into 4 into 10 to the power of minus 7 into 100 by 9. This 9 can be cancelled. That is the 9 placed in the numerator, and denominator will be cancelled. We know that if the bases are same, in the case of multiplication, the power can be added. That is x to the power m into x to the power n equal to x to the power m plus n. On applying that principle, we are going to write 10 to the power of 9 into 10 to the power of minus 7 into 10 to the power of 2 as 10 to the power of 9 plus 2 minus 7. The 4 is written as it is. So if we add this power 9 plus 2, we will get 11. 11 minus 7, we will get 10 to the power of 4. 4 into 10 to the power of 4. So now we have calculated the potential at a point P due to the charge of 4 into 10 to the power of minus 7 coulomb located 9 centimeter away as V equal to 4 into 10 to the power of 4 volt. We know that the charge will exert the force, that is electric field. At this electric field, there will be different potentials at different places. If the distance is increased, the potential will be decreased. Why? Because the potential is inversely proportional to the distance. Next, we are going to find the work done to bring a charge of 2 into 10 to the power of minus 9 coulomb from infinity to the point P. Also, we are going to answer whether the potential depends on the path along which the charge is brought. We have written the unit for 1 by 4 pi epsilon naught as Newton meter square per coulomb square. How this unit arrived? We know that as per Coulomb's law, the force of attraction or force of repulsion between 2 point charges is directly proportional to the product of charges, that is Q1 into Q2, and inversely proportional to the square of the distance, that is R square. We know that the unit of the charge Q is coulomb. So we will get the unit for Q1 into Q2 as coulomb square. Then we are also knowing that the unit of the distance is meter. Here there is R square, so that we are writing as per meter square, because here the R square has placed in the denominator. So from this we can write the formula for 1 by 4 pi epsilon naught. If we change the sides, we will get 1 by 4 pi epsilon naught Q1 Q2 by R square equal to F. So if we bring the other factors to the right side, it will become as, that is Q1 into Q2 will come to the denominator and R square will be placed in the numerator. So we are getting the formula for 1 by 4 pi epsilon naught as F R square by Q1 into Q2. What is the unit of force? The unit of force is Newton. What is the unit of distance square? The unit of distance square is meter square. What is the unit of Q1 into Q2? Product of two charges is coulomb square. Since it comes in the denominator, we are writing as per coulomb square, so that we are obtaining the unit for 1 by 4 pi epsilon naught as Newton meter square per coulomb square. Now we are coming to do the second sum, that is B. In B, they are asking how much work is to be done to bring a charge of 2 into 10 to the power of minus 9 coulomb from infinity to the point P. At the point P, we have calculated the potential, that is V, as 4 into 10 to the power of 4 volt. This potential V equal to 4 into 10 to the power of 4 volt is the work done to move the unit positive charge from infinity to the point P. Now we are going to find the electric potential energy, not electric potential. That is, we are going to find the work done. That work is done to move the charge 2 into 10 to the power of minus 9 coulomb from infinity to the point at which we have found the potential as 4 into 10 to the power of 4 volt. So the formula for the work done is W equal to 1 by 4 pi epsilon naught Q1 Q2 by R. We can also write this formula as W equal to 1 by 4 pi epsilon naught capital Q into small q by R. The capital Q is the source charge. Now this Q1 is the source charge. This Q2 is the test charge. We have already determined 1 by 4 pi epsilon naught Q by R as 4 into 10 to the power of 4 volt. So we can write 1 by 4 pi epsilon naught Q by R as capital V, that is potential. Thereby we will get the formula for work done as V into Q. In this formula there are 3 data. one is on the left side and another two on the right side. If we know V and Q, we can find the work done. As already discussed, we are knowing capital V, that is potential, and also the charge which is brought from infinity. Since we are knowing these two data, that is V and Q, we can proceed to find the work done, that is W. If we substitute both the data, we will get the work done W equal to 4 into 10 to the power of 4 into 2 into 10 to the power of 9. If we multiply 4 into 2, we will get 8. If the bases are same, in the case of multiplication, we can add the powers. If we add the powers, 4 and minus 9, we will get minus 5, that is 10 to the power of minus 5. The unit of the work done is joule. The work done is also called electric potential energy. Electric potential energy is denoted by the letter capital U. The work done is stored as electric potential energy. In the case of the last question, that is, does the answer depend upon the path along which the charge is brought? The answer is no. The work done does not depend upon the path along which the charge is brought. The work done depends only the charge and the distance. In other words, the work done depends only on the initial and final position of the charges. It does not depend upon the path. In whatever way the charge is brought. My dear students, if this video is really beneficial to you, you can share with your classmates and friends. You can also subscribe my channel.